अभी नहीं पूछ सकते ना, नेक्स्ट क्लास।
नहीं, आप पहले ट्राई कर लीजिए, ठीक है? हो सकता है आपका फिर से कैलकुलेशन ऐसा नहीं है कि आपने वन टाइम किया, वन टाइम एक ही शॉट में आपका सही सब कुछ, कहीं पे स्टेप में कुछ गलती हुआ है।
हाँ
पहले
सर,
वो ट्राई।
बट सर हाँ, मैंने मतलब क्लासमेट से भी कंपेयर किया तो उन लोग का भी मतलब 8 ही आ रहा था सर टर्म्स, मतलब प्रोसेस जो था वो हम लोग का ऑलमोस्ट सेम ही है सबका, फिर भी 8 आ रहा था सर।
लेकिन correct answer is when I'm completing this particular example, my answer is 11. I don't know, and when we will discuss that particular question, that time you will check. Okay, ये क्वेश्चन में फिर से आप लोग ट्राई कीजिए। ऐसा नहीं है कि सबका 8 आया तो आप मतलब पढ़ना बंद कर देंगे क्या? If every students getting our same answer, number of terms are 8, then you will stop from your side.
No,
सबका तो गलत भी हो सकता है ना? So what I am saying that you will try yourself. Some particular steps are wrong, क्योंकि जैसे आपने पूछा ना, उसने भी किसी को पूछा, तो शेयरिंग मोड पे आप लोग रहते हैं, मालूम है मुझे। तो एक गलती करेगा तो उसका इंडिविजुअली एक गलती करेगा तो दूसरा भी कॉपी मारेगा, तो ऐसा ही इस टाइप का होता रहता है। तो मैं क्या बोल रहा हूँ कि आपने अगर खुद किया है तो बहुत अच्छा है, फिर से ट्राई कीजिएगा और वही चीज को रिपीट मत कीजिएगा। मैं बोल दिया हूँ ना, एक दूसरा क्लास में लूंगा, उसमें से जितना भी होमवर्क है, जो भी डाउट है, वो मैं क्लास में डिस्कस करूँ। हाँ,
ओके सर, थैंक यू सर।
So today we are discussing the combinational circuit. Though yesterday we are discussing little bit about the combinational circuit. Okay, so obviously there are different type of combinational circuit are there: adder, subtractor, multiplexer, demultiplexer, encoder, decoder, and many more. Okay, suppose here I am not including comparator and all those things. Because why this is called a combinational circuit? Because output always depend on the present input. There is no concept of memory. Okay. So we are discussing about the design of half adder. So half adder means what? We are using two inputs, only 2 bits we are adding. And always remember, someone is asking you what is the input of half adder. Then your answer is 2. And what is the output? How many number of outputs in half adder? 2. One is S denoted as a sum and C denoted as a carry. Okay, normal 2 bits. When we are adding the normal 2 bits, that time what happen? If sum is generated, then you can put the value, and if it is carry generated, then put that particular logic value. This way we can draw the truth table, and truth table is nothing yet. It is the behavior of that particular circuit. Okay, and obviously from the truth table we can generate the expression of sum and the expression of C. Okay, here S is equal to what? A B bar plus A bar B, and indirectly we are writing the another form is that A XOR B. Okay, A B bar plus A bar B means what? It is A XOR B. And what is the expression of C? C equal to A B. Okay, so this is the normal, that means we can draw here we are using not get because this one is the B bar, and after that we are the A B bar, we are using some particular AND gate, and after that when we are adding the two terms we are using the OR gate. Okay, something like that. But what happens if someone is asking you to design the half adder using NAND gate? So that means what? You can modify this expression such that when you are designing the circuit, all the gates must be a NAND gate or NOR gate. Okay. So it is how you are. That means what? Obviously, simplification of expression is required. The concept of the simplification of expression is required. So till now, whatever we are discussing, all the previous class, we are doing some type of expression, how we can use the exams rules and some particular laws and all those things you can apply when you are simplified the expression. Okay. So next, this one you are trying, and till now, that means those students are showing this particular answer. All the answers may be wrong, but you don't worry, you can try yourself, and also you can take the help of book. Okay, at first you can try yourself. After that, you can cross check where is my fault. आपको फॉल अगर करेक्टली आप लोगों ने फॉल निकाल पाया, then you can know better. Okay, so you can identify where कहाँ पे मेरा fault हुआ है. Where is the location where I am doing wrong. Okay. So next we are directly going to the full adder. Now previous class we are discussing the half adder. Now what happened? This is called a full adder. Full adder means what? What is the difference of full adder and half adder? It is the one similarity is there. we are doing addition both the circuit, full adder or half adder. Only difference is that here we are using 3 inputs and the output is 2 outputs. But remember what happened at first, we are considering as a 2 inputs, and after that whatever the carry is generated from that particular 2 inputs, that particular carry behave like as an input. Are you getting my point? So what happened here, if more than 2 inputs we are using, that time what happened, we are using the full adder. No, this statement is wrong. Full adder only manipulate with the 3 inputs. Okay, so n bit number, n bit digit, n bit binary numbers, how we can manipulate it, that is the different issue. That particular part we will discuss later. But someone is asking you how many inputs are, 3 inputs are required, and 3 bits we can manipulate with the help of full adder. And obviously you know S means what? S means sum and C means carry. Now this is the truth table of half adder. So you know how we are getting. At first what happened, x plus y, the value is 0 0, 0 plus 0 is 0, and after that what happened, when we are using the 0, the carry is generated is 0. So 0 plus 0 is 0, and after that we can add with the carry, 0 plus 0 is also 0. So here I am writing S equal to 0 and C equal to 0. Now see here, 0 plus 0, yes, good, 0 plus 0 is sum is 0, okay, but there is no carry is generated. Okay, so what happened, there is no carry is generated, that means it is 0, and 0 plus 0 means 0, and 0 plus 1 means what? This one is 1. Okay, we are taking we are taking some particular combination of carry. Okay, the same thing, what? 0 plus 1 is 1, and 1 plus 0 means what? 0. No, sorry, 1. So we are getting sum equal to 1, but there is no carry generated, so C equal to 0. So see here in this particular case 0 plus 1, yes, 1, and 1 plus 1 means what? 1 0. Okay, 1 0 means what? Sum is 0 and carry is 1. So I'm writing here 1. Okay, so 1 plus 0 means what? Obviously what happened, 1 plus 0 0, sorry, 1, and 1 plus 0 is 1. So sum is 1, and this way we are doing. Now last case, see here, 1 plus 1 plus 1. So 1 plus 1 means what? 1 0. Again we are adding with 1. So 1 1 is coming. So sum is 1 and carry is 1. So this one is sum is 1 and carry is 1. So this is the behavior of full adder, and that particular behavior we can represent it with the help of truth table. Now see here, so from the truth table we can directly write this particular expression. This is the expression of sum from the with the help of truth table, and this is the expression of xy. Okay, so how we are getting this particular one? So see here, you can check this one. You can convert this particular, if from the truth table you can easily find out the mean terms. Okay, so when you are finding the mean terms, and what is the mean terms of S? So where is 1 is present? This one is 1. This one is 2. This one is sorry. This one is 1. Sorry. This one is 1. This one is 2. This one is 3, and this one is 7. So you can construct the truth table. No, sorry, KMF. Okay, then you can find this particular expression. Okay, you can find x bar y bar z plus x bar y z bar plus x y bar z bar plus x y z. And what is the mean terms of C? Mean terms of C is what? 0, 1, 2, 3. Mean term is 3. Okay, and after that, what happened? 3, 4, 5. This one is 5. 3, 5, 6, 7. So from when you are getting the mean term, then you can automatically draw the KMF. And when you from the KMF, whatever the expressions you are getting, this is the expression of C. C means what? Carry. And after that, what happened? From this particular expression, you can easily draw the circuit. So what type of gate we are using from this particular circuit? We are using the NOT gate, AND gate, and OR gate. That means we are using the basic gates. Okay. So I am not draw the circuit. You can draw yourself, because if you are getting the expression, then it is very easy to design the circuit with the help of basic gates. Okay. So any doubt this one? Can you any doubt? Then please ask me. So how we are getting this particular expression? You are getting or not? Any doubt? Then please ask me. Okay.
सर
Yes.
सर
Yes, yes.
पिछले स्लाइड में जा सकते हैं एक बार?
Yes, sure. आप लोग अगर फिजिकली क्लास में प्रेजेंट रहते तो क्या करते? मैं ये बोर्ड में लिखा था, तो आप लोग डायरेक्टली कॉपी में लिखते। सो इट इज बेटर वही समझिए, आप लोग सामने कॉपी एक रख लीजिएगा। मैं बार बार बोल रहा हूँ कि बाद में आप लोग अगर ये मतलब एक्सपेक्ट कर रहे हैं कि सर मटेरियल देगा, ये मटेरियल क्या दूंगा? दिस इज नॉट ए मटेरियल, जस्ट आई एम प्रिपेयरिंग द पीपीटी रफ एज ए रफ। Okay, and this subject and any of my subject you are asking any senior, I am not providing any type of materials. Okay, sometimes what happens, some particular materials are required, that time automatically I am, without you are saying, automatically I will provide you. But आप अगर एक्सपेक्ट कर रहे हैं कि इस टाइप का मटेरियल मुझे मिलेगा, सर का स्लाइड मिलेगा, वो जस्ट फॉर अंडरस्टैंडिंग पर्पस आई एम रफली प्रिपेयरिंग दिस पर्टिकुलर स्लाइड। ओके, हाँ आपने ये
हो गया,
हाँ
थैंक यू।
ओके, now what happen is if we are using full header with two half headers, how these particular statements are coming? Because this particular statement is some designer is proved this one, so they are writing this way. It is possible. So that means what is the meaning of this particular statement? We can construct the full header with the help of two half headers and or gate. Or here I am writing or gates. Now I am writing or gate, remember that means what? Here I am writing only gate, that means only one or gate is required. Here I am not writing or gates, GATES, I am writing only GATE. So that means what? We are using some particular one or gate and two half header we are using. So for that particular purpose, what happen? We can manipulate this particular expression. See here, if you are not, just you can carefully check this particular all the steps, this one, this one, this one. Don't go for C right now. Just you can concentrate with S and this one. You can carefully check, and if you are getting any doubt, then please ask me. Don't hesitate, please ask me. It is okay?
यस सर।
ठीक है, आप लोगों ने यस सर बोला, आप लोगों को समझ में आ रहा है। बाकी लोग जिसको समझ में नहीं आ रहा है, आप हेजिटेट मत कीजिए, पूछिए, प्लीज आस्क।
आ गया सर समझ में।
आ गया, ठीक है, वेरी गुड। So we are doing nothing, just we can apply the Boolean expression rule. Okay, remember one thing, this particular part is very important. From this, how we are getting x bar y plus xy bar and the whole complement. So just you can simplify, and after when you are going to simplify this one, you are getting x bar y plus xy bar is whole complement. This one is the whole complement. This one, it is the whole complement. Okay, and when we are using this particular complement, suppose this one z is considered as a bar and x or y is considered as a b. So a bar b plus, again what happened, z is here non-complement and this one is complement. So that is the rule of XOR. Oh, just a minute. Here I am. Okay. So sorry, here I am not writing one particular expression. After that, I am getting this one. X bar. Sorry, X bar, XOR Y, and XOR Z. Or you can write this way also. The meaning is same. If you are don't writing the bracket, then also it is no problem. So from this particular expression, we can write this way also. Now you are getting? Because see here, Z bar is Z bar. The first term we are writing is a Z bar, but second term there is no complement. In first term, second particular x or y is non-complement, but in second term x or y is complement. So what happens? Just it is vice versa. When it is vice versa is doing that time, what happens? Directly we can write this way. Okay. Okay. Okay.
Yes, sir.
Okay. And
Yes, sir.
this particular C also, C expression, this is because this one is the minimized from. First one, this one is the minimized from we are getting from the KMF. Okay, don't confuse. This one and this one, this particular expression is the minimized from we are getting from the KMF. But what happens when we are using when we are implementing the full header with the two half headers, then this particular C you can take the expression from the truth table. Okay, from the truth table I am getting this one. This is not a minimized form. After it, you can apply some particular rules, Boolean rules, and from that particular rules, I am getting this. Okay, it is okay because what happened here? X bar y plus x y bar means what? It is x or y, and z is already here. Okay, and after that, what happened? Z plus z bar means what? Equal to 1. So I am writing here x y. It is very simple. When we are using this one, that time what happened? After that, we can draw this particular circuit. You can carefully this particular circuit. So you know what is the half header, how you can implement the half header. Okay, so what happened? Here we are using two half headers. Okay, how we are using the two half headers? Here, which one we are considering as a half header? So this particular part is a one half header, and this particular part we are considering as a one half header. And here what happened? We are only using one OR gate. For C, we are using one OR gate. And how we can draw this particular circuit? With the help of this particular two expression. X, XOR Y, XOR Z. So what happened? Here at first X, Y, that means what? Here we are getting X, XOR Y. Okay. After that, what happened? This particular line is connected. This is a Z. That means what? X, XOR, X, XOR. We are getting X, XOR Y and Z. Y, XOR Z. Okay, Y, Z. And after that, what happened? See, this one is complete. For S is complete. S is complete. And what about C? C means what? C means what? It is X, XOR Y. So we are connecting this one because this one is already X, XOR Y, this particular line. We can connect. Okay, it is no problem. After that, what happened? Z. Z multiply with X, XOR. Here see this one. Z multiply with X, XOR Y. So which one is the Z? This one is Z. We can connect here. And this particular two terms related with AND operation. So I am using the AND gate. This one is the AND gate. This one is the AND gate. This one is complete. And after that, what happened? After that, XY. So XY we are using another AND gate. Okay. So this one is what? Y, and this one is X. This one is Y, and this one is X. It is connected with another AND gate. This one is AND gate is completed. After that, what happened? We can add with plus. So what happened? Here we are using only one gate. Plus means what? OR gate. We are using OR gate. Okay. So this is the special case. If someone is asking you, you can implement the full header with the two half headers. Then you can do this one. But what happened? So there is alternative circuit is there. So whatever we are discussing the earlier, that means that if we are using this particular part, this particular S and C, okay, this particular part, then also it is correct. But if someone is asking you, forcefully asking you and giving the constraints to you, then you can implement the full adder with two half adders and an OR gate. That time what happen, you can draw this particular circuit. But if it is, they are not, by default also you can use this particular circuit because it is shortcut. Okay. And if it is not, that time what happen, normal from the S expression and C expression, we can draw this particular circuit, this one. Okay. Why I'm using this particular circuit, see here, always remember, when some particular level means what, some particular circuits are there. Okay. And here we are using some type of gates. Here we are using one gate, and suppose here we are using one gate. Suppose this particular black box is gate. Suppose number of gates we are using. Okay. And here we are using one particular gate. Okay. That type of gates. So how many levels are there? How we can consider? So what happened? This is the input. Okay. Input is level 0. We are considering level 0. So this one is level 1, this one is level 2, and the output is what? Output is, we are not considering output as a level. So what is the intermediate level? Okay. So what happens, every level when we are crossing, that time what happens, some particular delay is occurred. So during the competition, it is some time is required. Okay. So that particular delay, suppose we are considering as a delta. Now what happens, assuming, see here in this the first point, assuming that the delay of all the basic gates is when we are using AND gate, or we are using OR gate, or we are using NAND gate, always what happens, it is required delta time. Delta, this particular delta. Okay. Now see here, why carry in based on this particular circuit, why carry is 2 delta. See here, this is the normal input, and this is the one level, and this is the another level. So delta plus delta means what? Delta plus delta means 2 delta. So when producing the carry, it is 2 delta is required. Now you are asking me, then why is 3 delta in S? Because we are using only one gate. Yes, though we are using the XOR gate, but you remember when we are implementing the XOR gate, 3 basic gates are required, AND, OR, and NOT. AND gate is required delta, OR gate is required delta, and NOT gate is required delta. So delta plus delta means 3 delta. So S means when we are breaking this particular gate with the help of basic gates, that time what happens, there are 3 levels are created, so it is 3 delta. Any doubt? Any doubt?
No, sir.
Yes. Now, till now we are talking about the full adder, half adder. Okay. But you know, what is the restriction of full adder? Full adder, we are using only 3 bits. And when we are using the half adder, we are using only 2 bits. But how we can manipulate with the n bit? So for n bit parallel adder, this one is called a parallel adder. So there are different type of parallel adders are there. One is ripple carry adder, one is carry loop ahead adder, and some particular advanced portions are there. This is not a your course, but though we are discussing. So carry select adder and carry safe adder. So carry safe adder is not required. Too much things are not required. So but ripple carry adder and carry look ahead adder is most important. Now, before we are going to discuss about the ripple carry adder, at first we know what is parallel adder. Suppose what happens, this is the addition. This is the adder, normal adder. This particular black box is normal adder. Okay. And here we are using 2 inputs. Here I am using 2 inputs, not a 2 bits. Remember, inputs are something different and bits are something different. Okay, here we are using 2 inputs, X and the Y. And when we are writing this type of symbol, that time what happens, this particular X contains n bit. This is the symbol of, this is the cross symbol, that means inclined line is this particular X has a n bit and this particular Y has a n bit. This is the symbol. Okay, there are some particular n bits are there. And when generating the sum bit, also there are n number of bits are generated. So I am using here this one. But when we are using the carry only produce the 1 bit. So I am using only single line, and here no inclined line, I'm not using any inclined line. That means what? Only one bit is generated from the carry. And when we are using this particular double arrow, that means this particular symbol and this one, that means what? We are using the sum contains n bits. So now what happened? This structure is called a parallel adder or n bit adder. You can say also n bit. N bit means what? N bit parallel adder. Or you can, some particular books they are mentioning only n bit adder. So n bit adder and n bit parallel adder are same. Okay, good. Now, based on this particular concept, we are discussing what is a ripple carry adder. First one. So cascade n full adders. N full adders means what? N number of bits. N bits. That means cascade n bits full adder to create a n bit adder. Sorry. Cascade not a n bit here. Cascade a n full adders. So how many number of full adders we are using? N. N number of full adders we are using. N may be 3, N may be 4, N may be 5, whatever. And after it, what happened? From this particular full adder, we are creating the n bit adder. And whatever the carry output is generated from every full adder, that time what happened? It is from stage I may be 1, I may be 2, I may be 3. From stage I propagate as the carry input to the next state. That is means what? I plus 1. If I is a present state, what is the next state? I plus 1. So that particular generated carry is propagated to the I plus 1. And this particular carry is generated from stage I. I'll discuss here. I'll discuss this one properly. And in worst case, what happens? Carry ripple through all the stages. That means what? All the carries are, it is passing all the stages of I. Okay. Suppose how this particular ripple carry adder actually we are using. But till now we are not discussing the details of the block diagram of the ripple carry adder. But before we are discussing the block diagrams, your concept must be clear in this particular basic concept. See here, at first what happened? There are two numbers. First binary sequence is the n number of bits. This one is what? N number of bits. And this one, what? This is the input of A. That means A means what? It is maybe an minus 1, after a dot, a2, a1. So this is the number of n bits numbers. A contains what? N bits numbers. And what happened? Obviously B, the equal number of n bit numbers. Okay, how many bits are there? 1, 2, 3, 4, 5, 6, 7 bits we are using. Okay, so number of cardinality of bits also, A also 7 and B also 7. Okay, this and second binary sequence we are using, we are considering as the input is B. Okay, suppose b n minus 1 b2 b1 b0 something like that. Okay, this n number of bits. And this particular red color I am using carry, whatever the carry is generated. You can carefully check this particular part. Already we have discussed, suppose lecture 3 or lecture 4. See here, 1 plus 1 means what? It is 1, 0. So initially what happened? When we are adding this particular number, carry is 0. Okay, fine, carry is 0. And when we are adding 1 plus 1, that time what happened? 1, 0, 0 is sum and 1 is carry. So that particular carry is propagated to this one. Again what happened? 1 plus 1 is 0 and again carry is propagated. So this one is the next carry is propagated. Again what happened? 1 plus 1, the carry is propagated. Lastly what happened? We are going this way. Are you getting my point? So what happened? Last particular part what happened? When we are getting 1 plus 0, 0, that time what happened? This particular carry is generated. That means sum is generated. This is all our sum. And when we are adding this one, what is the carry? Now carry is 1. So this way we can adding the n bit numbers. Okay, are you getting my point? So that means what? Now finally what happened? We are using, finally this is the, whatever we are getting the binary sequence, that is called a sum. And when we are doing the processing, this type of carries are generated in every stage. So this one is the stage 0, suppose this one is the stage 1, this one is the stage 2, stage 3, stage 4, stage 5 and stage 6. So that is the meaning. Okay. Now, what is the block diagram? And if we are using this particular concept, with the help of block diagram, how we can show. This is the block diagram of ripple carry header. So see here, initially what happened, Ci in equal to 0, because thus we are starting point. So that time what happened, this particular full error behave like as a half error. Though people are using the full error, but what happened, initial full error, if we are considering as a half error, then also it is no problem, because we know half error only 2 bits, 2 inputs are required. Okay, so what happened? So obviously, why we are using the first, why we instead of full error, why we are using the full error? Because what happened, we know that C in always equal to 0, because this is the initial point. So if instead of full error here we are using half error, okay, then what is the benefit for us? Because what happened, competition cost is less, and also the, because full error is the full error costly than the half error. Okay, so instead of full error we can use the half error, but if you are writing here full error also, then if you are using the full error, then also no problem, because always C in equal to 0. And after that what happened, 2 bits we are using, 2 input bits. So A0 B0 plus C in equal to 0, and whatever the outputs are produced, this is called a S0. And if it is carry generated, that time the carry is propagated to the next stage. Now what happened, we can add, now it is full error is required, we cannot use any half error, because what happened, C0 may be 0 or maybe 1. So that means what, A1 B1 and C0, when we are adding with the full error, that time what happened, some particular sum is generated, we are giving the name as a S1, and whatever carry is generated, that particular carry is propagated to this one, that is called as C1. And this particular process is going on, and I am showing only 4-bit ripple carry order. It is maybe n-bit carry order, C3 C4, and after that when A3 B3 is coming, after that A4 B4 is coming, this process is continuous. Thus I am showing for 4-bit ripple carry order. If it is generalized, this particular block, if generalize the expression from this particular block diagram, then how we can write two numbers, it is going an minus 1 up to a2 a1 a0, because we are starting from 0, so I am writing n minus 1. If you are starting from a1 b1, then it is an. Okay, the same way this one is the bn minus 1 b2 b1 b0. Now what happened, the input carry means what, initially we are providing only one particular input carry, so it is C0. So that means this particular is 0. Initially we are considering 0. So what happened, input carry is, first input carry is produced C0. So first input carry is C0. And whatever this particular part is called as sum. Sum means what? If we are considering S3 is a Sn, that means n equal to 3. So here I am writing Sn minus 1 dot dot S2 S1 S0. And the final output, this one is called a output carry. So what happened, if you are using n-bit number, so here I am writing n. So here what happened, this one is the how many, n equal to what, n equal to 3, and it is starting from 0 to 3. So here I am writing C3. Okay. Now see, when we are using the ripple carry order, how we can delay for C1, Cn, that means how we can compute the delay. See here, you know the full error, because we are using the full error. Here we are using full error, all are we are using the full error. But this one, the first full error is the special case. You can, though you can use the full error. Suppose we are assuming that we are using all the full error. So that time what happened? How we can, you remember when we are using the full error, how we can draw the circuit? Okay, and what is the expression of X, and what is the expression of C? C means what, carry, and S means sum. So that means what, when we are using the carry, that time what happened, we are using one AND gate and one OR gate. Okay, that means what, only two levels are there. So what happened, AND gate, this particular, from this particular definition, from this particular definition, and whatever gate we are using, AND gate OR gate, that means what, only one delta is required. So what happened, if we are using two levels, that time what happened, one for AND gate and one for OR gate. That means what, the two delta plus delta means what, it is two delta. Again, what happened? This is the suppose we are considering C1, C2, but you can consider from C0 also, no problem. So, but what happened if C0 is 2 delta? That time what happened? This particular suppose this particular C1 is suppose 2 delta. Okay, then 2 delta again generated, this particular full adder is again generated 2 delta. Okay, and this is the already propagate to this particular one. So what happened? C2 2 delta plus 2 delta equal to 4 delta. So what happened? We can multiply with 2. C1 we can multiply with 2. C2 we can multiply with 2. And when we are considering Cn minus 1, that time what happened? 2 multiply with n minus 1 delta. Okay, and finally the final C3, that means Cn, suppose n number of bits we are considering, then final is Cn equal to 2n delta. So when we are using the ripple carry adder, someone is asking you, we are using n number of bits, then what is the delay for Cn? Then directly you can put the n value and directly you can get the what is the delay of Cn. Now what happens next? How we can compute the delay of sum? So already you know, that means what? We are using, that means S0 also we can write, when we are finding the sum in half adder, we are using the XOR gate. So XOR gate is nothing but we are using NOT gate, AND gate and OR gate. So 3 levels are there. So whatever initially we are getting S0 equal to 3 delta. Okay. Now what happened? See here, C0 is propagated to S1. So C0 means what? C0 we know from the any particular carry we are using what? 2 delta. So 2 delta plus 3 delta. 3 delta means earlier what happened? We are using the 3 delta is common for sum. So it's 3 delta. And that this particular carry is added to the another adder. So C0 means what? It is 2 delta. So 2 delta plus 3 delta means what? We are getting the 5 delta. Again, we are using the sum. So sum means what? Sum means every sum it is 3 delta is produced because AND, OR and NOT gate. Okay. And after that, what happened? We are using some particular carry bit we are using. So carry is propagated to the what? This one is the 2 delta. Then C1 means what? 2 into 2 means what? 4 delta. So here it is 4 delta. So 4 delta plus 3 delta is what? 7 delta. If you are using n minus 1, that means what? Every time what happens? We can multiply with 2. Someone is asking what is that? Because what happened? Every time we are using n minus 1 because we are starting from S0. Okay. So S0 to S3. That means 4. If we are using 4 full adder, 4 bit, that time what happened? What is the range of S0 to 3? So what happened here? I am writing 3 means what? Total number of is 4. So n minus 1 means what? It is 3. So here I am writing n minus 1. Okay. And when you are breaking this one, you are getting 2n plus 1 delta. अरे भैया चुप चाप मत बैठो, कुछ तो पूछो. Anyone hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
you are getting, yes, good, very good. You are facing any problem to understand this particular concept? You can ask anything. How we can finding the delay of carry and how we are finding the delay of sum. Okay, so what happened here? Two numbers we are using, we are denoting as A and B. And in A, we are using n bits numbers. And when we are reading the n bits numbers of A, that time what happened? We are reading from MSB to the LSB. So how we can read? AN minus 1, A2, A1, A0. Okay, that is the input for A. But again, what happened? Full adder, at least 2 inputs are required and the other is 3 inputs are required. 2 inputs and 1 is carry. So what happened? The other input is B, and B is also contain the same number of n bits. So we are denoting as a from the MSB to the LSB is Bn minus 1 dot 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 B2 B1 B0. This is the generalized formula, generalized diagram. But here in this particular block diagram, I am using 4-bit only 4-bit ripple variator. You can extend any bit ripple counter. So what happened initially? What happened? Initially, CIN is 0 means we are not considering initially. So our main input carry is starting from C0 from the whatever the generated from the first letter. Sorry, first full letter. So I am writing here input carry equal to C0. And sum we are getting from this particular block diagram, you can easily consider as n minus 1 to S0. And final carry, whatever the final carry is there, that means that is called an output carry and C. So always remember when we are using C1, only two levels are there. One is AND gate, one is OR gate. So what happened? The earlier slide, we are clearly defined that if one particular level is crossed with the help of basic gates, that time what happened? The delay time is delta. So we are using here N and OR gate. So two levels are there. Delta plus delta is 2 delta. So delay for C1 is 2 delta. And with the help of C1, S2 is created and C2 is created. So what happened? We can take the value of C1 2 delta, and for C2 is required 2 delta. 2 delta equal to 4 delta. Yes?
Sir, we are having math class next. Can you finish it?
Okay. Just a minute. What is the time?
Sir, it's 11:05 now.
11.
Okay. Then but remember one thing. Most probably your second internal exam I will not conduct it, because from my side it is no problem. But what happened? If I'm conducting the second internal exam, that time many things are left. So last internal exam you have a huge load. So I will announce later. Most probably 22nd or 21. First internal exam. No, sorry, second internal exam.
Yes, sir.
Maybe it is postponed, maybe it is delayed. Okay, I will announce the date later. Okay, because what happened, if unit 2 is completed, then it is okay, then I will conduct the second, but I don't think so the unit 2 will be completed. So most probably in the month of November I will conduct the second internal exam, but I'm not clear time now. Just I'm giving you the WhatsApp, and any other the WhatsApp I will provide the information, or otherwise next class I will inform you. Okay. And I don't know, you just regularly check the WhatsApp. Most probably Saturday I will take the class. But if you are not getting information through the WhatsApp, then you automatically understand that the class will not conducted on Saturday. If you are getting any information, then you can attend according to that time and date. Okay. Just you leave one by one.